Hello friends, welcome back to the latest video on StatPro for fresh civil engineers. Up till now we have discussed all the different basic commands used in the StatPro. Now from today's lecture we are going to start actual modeling and analysis of the different type of elements like beam, then frame, then truss, and then the completely G+3 RCC building. Right now in today's video we are going to discuss the analysis of a single span beam subjected to different type of loading conditions. So let's begin with that. So open StatPro, start with the new project, select plane. Now I'm giving the name as beam 1. Next, right. So now initially we are going to discuss a beam which is simply supported at the ends and gets subjected to a uniformly distributed load of 20 kN per meter, and the span of the beam is 10 meter. So first of all we are model the beam and then we perform the analysis of the beam. So here first start with the beam. Initially you can add the beam by adding the nodes and or directly by using the grid also you can mark the beam. So selecting the front view. Now let's draw the beam of a 10 meter span. Let's switch off the grid view. So this is a beam of 10 meter span. Then next job we are going to assign the property to the beam. So select the general. Let's go with the first property. Here define rectangular section. Let's take a cross section of 0.3 by 0.3 meter depth and width. Add, close. So select this view, then use cursor to assign. Select the beam, then assign. Do you want to proceed? Yes. So cross section is get assigned to this beam. Now next job is go to the support. Now first of all creating the support. So as here it is shown the simply supported beam. So here I am adding a pin support or hinge support. So add the support, then select the support. Here I am selecting the node cursor. Select the nodes, then assign to the selected nodes. Assign. Do you want to proceed? Yes. So at both the ends a hinge support or simply support is get assigned. Now next job is load. So now you have to go in the load case details. Add any different type of load you can consider over here. Let's say I am considering the dead load, giving the name as load case 1 only. Add over here, then close. So in load case 1 we are going to add. Now our beam is a simply supported beam subjected to uniformly distributed load of 20 kN per meter. So here I am adding a member load. In that one uniform force, the value of the load is whatever it is given, that is 20 kN per meter. So here 20 kN per meter. The minus sign as the load is acting in downward direction, global along y direction. Then add this load, close. So select the load, then use cursor to select the beam and then assign to the selected beam. Assign. Do you want to proceed? Yes. Now let's reduce the view of the load by selecting this option. Okay, now the simply supported beam is given with the load. You can give the load values in the labels, put the load values. Okay, so here you can see 20 kN per meter load is get assigned to the simply supported beam. Span of the beam is 10 meter. Now this up to this the modeling of the beam is done. Now next is we want to analyze this beam. It means that we have to plot the shear force diagram, bending moment diagram. Also we have to determine the reactions at the support. So select here analysis and print. In that one, here you can select all, then add, close over here, then perform analysis print, all, assign, and then go over here, analyze, run analysis, save. So here 0 errors, 0 warning. Okay, close means the output is get generated. Sorry. Now you can go over here in the post processing mode, load case 1, apply, okay. Okay, so now you can see over here the displacement of the beam is get displayed. Again the values of this displacement is given in tabular format also, or here you can see the deflection curve. You can click on that curve and maximize this view. Then by scrolling up and down here, you can pressing the control and scrolling the scroll bar, here you can increase or decrease this size of the deflection curve for the purpose of visualization. Then similarly here, considering the Fy, that is nothing but the shear force diagram. Again by pressing the control key and scrolling the bar, you can actually increase or decrease the size of the figure for the purpose of visualization. Again here next M of Z, you can see the bending moment diagram and the maximum bending moment at the center. Now you can go over here in reactions. Here you can see the reactions at the support 100 and 100. As the span of the beam is 10 meter, load is 20 kilonewton per meter, so 20 into 10 it will be 200, and 100 are the reactions as it is a symmetrically loaded. Then you can see over here the value of the reactions at loads, then the reactions. Similarly you can see the value of maximum bending moment also. Again here you can go in the reports. Now in report you can see here the report setup is available. In that available is input and the output. So whatever the things we required, suppose in output I required the value of node displacement, then node displacement summary, then beam end force. So the point of which we require the information that I am selecting, that is beam maximum bending moments, beam end forces, and OK. So here you can see a report is generated in which the job information, initial page, and then the beam end forces, that is nothing but the reactions at the supports, as well as the values of bending moments are appeared over here. That is maximum bending moment is 250 kilonewton meter. So likewise you can generate the report also through this report options. Then again you can go over here in the modeling mode or again the post processing mode. If you select double click on the beam also, then also you can see over here the geometry of the beam is appeared, that is 10 meter span. Then cross sectional dimensions are 0.3 by 0.3. Property, the cross section is of concrete, so the values of material properties are mentioned over here. Then the loading, it will be get subjected to uniformly distributed load of 20 kilonewton per meter. Then in shear bending you will get the shear or bending moment diagram. Again in this you can get the value of bending moment at different distance or at different points from one end to the another end. Then lastly in the deflection also you will get the value of deflection at different points. So in this way also you can check all the details regarding the beams. And we know the standard case of the value of maximum bending moment is when it is subjected to simply supported beam subjected to uniformly distributed load is WL square by 8. So with respect to that the value will be checked. and this analysis will be done within a fraction of seconds by using this StatPro, right? So here by using this you can generate any type of apply the load and generate the beam. Now again next we are solving one more beam, that is nothing but the a simply supported beam subjected to a central point load of 50 kilonewton, right? So start with that. Let's draw a simply supported beam, again plane, then I am taking here beam 2, next finish. So now here taking the front view, a beam of 10 meter span, closing the view, then adding here the support conditions. So create a support, a simply support is created, add, then assign to view, support, assign, yes, so it will be get assigned over here. Then load case details. So in load case I am adding one load, let's say load case 1, close. Now in load case 1, now over here it is given that a simply supported beam subjected to a point load, and point load is acting at the center. So here in this beam I am adding one node at the center, so for that purpose I am adding a midpoint over here, that is okay. So that node is get added over here and beam is get divided into two parts, right? Now in load case 1 I am adding a load, a nodal load of minus 50 kilonewton at y direction, so here add, then close. So assigning this load, select the node cursor, select the central node, then assign to selected node, assign, yes. So considering this view, the value of the or the height of the arrow is get reduced, so the point load is applied at the center over here. You can mark the label also, load value, okay, the 50 kilonewton load is applied, right? Now next is analysis and print, all, add over here, close. So perform analysis, assign, then analyze, run analysis, save. Okay, now you can see over here the 4 errors and 0 warnings are coming. Now when you click done, then here those errors are mentioned. So here the error is of elastic modulus is mentioned, right? So here we made one mistake over here, that we are not assign the section properties to the section. Though in the analysis work the section properties does not play any role, but whenever you are analyzing any type of structure in StatPro, every time these section properties are to be assigned or it should be needed. So here for that purpose consider general, then property, defining a cross section, that is rectangular section. Let's take again point 3 by point 3 of the section, concrete, add, close. So select the section, assign to view, assign, yes, right? Now we can again go for analysis and print, all, add, then close. Perform analysis, assign. Now you can go for run analysis, so save over here. Okay, now that there will be 0 errors and 1 warning is there, right? Now if warning is there, there is no problem, but error should be 0. So now go in the post processing mode, apply, okay. Here you can see the deflection curve. Pressing the control and scroll down the bar, you can increase or reduce the size, then go for the FY or shear force diagram. So at the point load there is a sudden drop down, otherwise shear force remains constant. Then similarly we plot the bending moment diagram in z direction. Okay, similarly over here you can see the reactions. The 50 kilonewton load is applied at the center, so reactions are 25 kilonewton. Then here you will get the maximum bending moment value again, WL by 4. Again in reports you can generate the report for the beam forces as well as the beam maximum bending moment or any other input and output values that you can add or from here, like some material, which material is there, which type of supports are there, the input values. Then similarly the output values, even you can add the pictures also from here, right? So in this way you can plot the, as you have not selected anything, that's why here there is nothing in the report. Now again go in the modeling mode, right? Now here these are the standard cases, that is simply supported beam subjected to uniformly distributed load, similarly subjected to central point load. Now we are analyzing one more case over here, that is nothing but considered a simply supported beam subject. Here there is a hinge support, here there is a roller support. At one end 30 kilonewton, point load here 50 kilonewton, and UDL will be of 21 kilonewton per meter. Span of the beam is 8 meters. So this is a combination of different type of loads. So how to analyze again? Okay, now again consider the new one, plane. Here I am taking as a beam 3. Go for next, add beams, then finished up. Considering the front view, now adding the beam, the span of the beam here it is given now 8 meter. Okay, now closing the view. Now go for the general properties, define, take the rectangular section, and here let's take 0.4 by 0.4. you can take any size of the cross section as per your choice, there is no any standard for that. So assign to view, assign, yes. Now let's add the supports. So first one support I am creating a pin support, add over there. Now one more, let's add the roller support. So at roller support there is only one reaction, so consider that FY reactions and add that support. So support 2 is, select the node point, assign to the selected loads, assign, yes. Then support 3, select the another node, assign to the selected node, assign, yes, right? Now next is assigning the loads. So load and definition, load case details, add over here, load case 1, add, close, select the load case, then select add over here. Now first of all I am considering the nodal loads. One nodal will be of 30 kilonewton, minus 30, add. Then there is one more nodal load of minus 50 kilonewton, considering that, add. Then the next member load is uniform force of 21 kilonewton per meter, so minus 21 kilonewton per meter, add over here. Now selecting this, use cursor to assign, selecting the nodal bar, selecting this node, assign to selected node, assign, yes. Then selecting the another, select the node point, assign to selected node, assign, yes. And then the uniformly distributed load, taking the beam cursor, assign to selected beam, assign, yes. You can decrease the arrow height by selecting this option. So here all the 3 loads here get assigned. You can display the load values by labels, clicking on display load values, okay. So here it is minus 30 kilonewton, then minus 21 kilonewton per meter, then minus 50 kilonewton. Next go in the analysis and print, select all, add over here, then close, perform analysis, assign, then run the analysis, select the save. So again 0 errors, 0 warning, done. Can go in the post processing mode, load case 1, apply, OK. Now you can see here, this is a deflection, done. Let's check the, this is a shear force diagram, that is over here. This is a value during this, at the support there is a point load, so there is a value of shear force, and again within two supports there is a uniformly distributed load, so trapezoidal section will be there. Then again you can check the bending moment diagram over here. This is the shape of bending moment diagram. So that support we have added, that will be, we are releasing only Fy, and all the other conditions are restraint condition, so that will be nothing but the fixed type of supports again get added over there. So here this is a movement at that point. Okay, so considering this is the bending moment diagram. And now again you can go in the reactions, you can check the values of reactions over here, then similarly the bending moment values and all that. So in this way you can if I am removing this support over here, general, go in the support, so support 3, delete over here, okay, support 2, assign, and then again you can go for this analysis and print, all, add, close, perform the analysis, assign, then go in the analyze, run analysis, done. You can check over here now. So this is a shear force diagram, then this is a bending moment diagram, and here this is a deflection curve, right? So in this way you can solve any problem or analyze or define the shear force diagram, bending moment diagram. Even you can find out the values of stresses. If you go in this post processing mode, apply, OK, then here when you are selecting this beam you can get the values of stress diagrams also, even in the form of a graphs also, that this is a graph of bending moment, this is a graph of force, and this will be the graph of displacement, right? Even you can get the stress values also, or the stress develop at different cross section points also, that values of maximum stress, then profile stress point, that also you can get from this analysis. So in this way you can practice solving the analysis of single span beam subjected to different type of loading conditions. Okay, now in the next video we will see the analysis of continuous beam subjected to different type of loads. Till that, thank you.